All right, pre-calc, we are going to jump into the last thing in chapter 3 here. It is unit 4, chapter 3, and that's the mathematics of finance. So something that you could use, but it has a pretty peculiar use in the real world, right? Out of all the things we talk about, this one is something you could turn around and use somewhere. But having worked with, well, my wife works at the bank, I know there's a little more ins and outs than basic finance that we talk about here. So, a few extra questions you'd have to ask at some point when you go to make those investment questions. A lot of what we deal with, it's kind of like when you deal with in physics, and we talk about free fall and something's resistance to falling. Um, Here we're kind of leaving out some of those details as well, right? Often we use 9.8 meters per second squared, and we just say that's a free fall, and then we have to talk about the resistance as it falls, a little bit different. So one thing that you are most familiar with is probably this equation here. So P is the principal, R is the rate, and N is the amount of time that we want to invest something. So Quan Lee has $500. We're going to make this 1.07 compounded annually, which means we don't have to use anything fancy. But we're going to do this for 10 years. And what happens is you just plug it all in, right? You're going to use your caret 10. We should get $983.58 after 10 years. Pretty good investment. All you had to do is leave your money sit there for 10 years and you made that difference, $483 and some change. So that's pretty good. So what I really would want to know is, all right, so, but I really only have an investment goal of making $750 here when the investment will reach it. So what we're going to do is set it up as 750, 500, 1.07, assuming the same rate. We're saying how long will it take to get there? All right, so we're going to divide by the 500. Now that we have used our log properties, this becomes a whole lot easier. So we know this is 1.5 equals that 1.07 to the x power. And what we're going to do, we're going to hit it with the log, in this case, the natural log, and that allows us to bring this down and divide by the natural log 1.07. I must have been drawing some Christmas trees or something with this. I got to fix that. Yeah. So once we divide, we're going to find out that this is only going to take 5.99 years. Okay, which we kind of expected, right? Because after 10 years, it was almost $1,000. We're only trying to get 750, but that's going to be 6 years. So trying to set our goal there to how much time we want to leave our money invested. Okay, so that takes care of the first part. That's when it's straight up and we are compounded annually. So there's nothing extra to do. If we start to get something compounded more often, so this is where things get a little bit trickier as we move through these problems today. We're going to compound it monthly. So here's we have A is the amount that we're going to have for the total, right? P is the principal. That's how much we put in there. Not Dr. Ellis. You can't invest Dr. Ellis. That'd be weird. 1 plus the rate. Expressed as a decimal, like always, compounded k times per year for t years. Notice that k is in multiple places. And we're going to divide the rate, and it's also in the exponent. So we're going to step through and work with that. Okay, so Roberto has $500, 1 plus the rate 9%, 0.09. It's compounded monthly. So how often is that? That's 12 times a year, and it's 12 times how long will we leave that in there? 5. So we know the exponent becomes 60 there. All right, so calculator order, some things you're going to do is 0.09 divided by 12 plus 1, and then hit your caret. Have this number worked out already at 60, so we need whatever this decimal is plus 1 to the 60th power. Take that times 500. All right, so let's see where we're going to end up with. Okay, so let's give you some numbers as you do it. You got your calculator ready? All right, 0.09 divided by 12. Okay, calculator says 0.0075 plus 1. That sounds about right. And take that to the 60th power. All right, so I got 1.56568. I don't care what that is. I'm not going to round it off times 500. So final answer here, how much money will we have after 5 years? That is going to be, let's not use a highlighter, $782.84 after 5 years. When will the investment reach $1,000? $1,000. So he'd like to double his money is what we're talking about. So all these things are going to stay true, except for it becomes 12t. If you want to use an x there, as long as you understand what we're solving for, t, so we know we're talking about time. So divide out the 500. So we know 2 equals 1 point. We can get a decimal for all this, right? What was that, 0.0075? Hopefully we used that somewhere before. And 12t. And now what we're going to do, we're going to take the natural log of both sides, divide this out. So normally, at this point, we're not really going to write anything else in here. So whatever this is, we're going to divide it by 12. So let's see what we're up to. All right, so natural log of 2. All right, hit enter or use parentheses divided by natural log of 1.0075. All right, looks like we're at 97.7657. Okay, so that makes sense there. And then we have to divide that by 2. Nope, I'm sorry, divided by 12. Okay, so we're saying 7.73 years because this is the time. All right, so let's make sure we have this in perspective. After 5 years, we had 782, and we want to reach 1,000. So it should be more than 5 years. And last I checked, 7.73 years is more than 3 years. Why did I say 3? More than 5 years. I was thinking it's going to be about 3 more years because 0.73 of a year. So that's almost the whole way through the year. All right, so we can use those. That's how it falls into the chapter that we're in. So hopefully that helps out just a little bit. Now we can make these equations a little bit tougher to solve. Okay, so we're going to deal with the same thing this time. Vocab I'm going to highlight is compounded quarterly. All right, so we're going to change out this 12 and 12 into a 4, right? Because 4 quarters. Okay, so let's not get that mixed up at all. I hate when I do that. All right, $500 to invest. 1 plus, we are talking about, what was this? This is the same problem, right? Oh, no. What annual interest rate? So we're trying to find out what's the interest rate. The rate divided by 4. And he wants to double his money in 10 years. So it has to be equal to 1,000. And that means we need 4 times 10 out here. All right, so automatically we're just going to drop that and say that's 40. But I did want to show you what those numbers are and where they're coming from so we can work through it that way. So we're going to divide this by 500. So anytime we're doubling, right, it's kind of like half-life problems we dealt with before. We know it's going to turn into 2, 1 plus r over 4 to the 40th. All right, how do we get rid of that 40th power? Well, I don't really want to take the log. So what I'm going to do here is I'm going to take it to the 1/40th power. Yeah, that's a thing, right? You use the reciprocal power. We just normally don't do it with 1/40, but we can totally do that. So that'll take care of these. All right, whatever we get out of this, we're going to have to subtract this 1 out of here. And then finally, we're going to multiply it by 4 to get rid of this. Okay, so if we take care of all those things, what did I jot down here? At some point, we're going to end up at 0.0699. And if we move this over 2 places, we're talking about 7%. We could say 6.99%. I had this jotted down, so I'd have it in this video. It wouldn't take too long. But as we work through there, if you need more, then go ahead and let me know in class. All right. May also be familiar with PERT, right? The account balance, and the principal is invested. And we're using E here. Remember, that's just short of 3. So R is given as a decimal again, and that's the rate, and T is the number of years. All right, so Latasha is going to take $100, and we're going to put that into the bank here, compounded continuously. Okay, so I don't want to skip over our vocabulary. Compounded continuously, that's how you know when to use which equation. It's based on what they're telling us. So this is going to talk about 0.08, that's 8%, and 5 years. All right, so some things you probably want to do is figure out what that is. So we're going to find out that that's 0.4, right? 8 times 5 is 40. We have 2 decimal places, so we'll move that over, and that's what we'll deal with. Okay, so 0.4, so we need e to the 0.4 times 100, and that'll tell us how much money Latasha has after 5 years. And if you do calculation correctly, I believe we're at 149.18. All right, so it means 5 years, 8% compounded continuously. Here, the problem, I don't know too much about investing, right? But the problem is that she's not putting much money in to get started with. But she's basically getting 150%, right? Because she's going to keep the 100, so another 50%. She's getting $50 after 5 years. So that's not too bad for not doing anything for it. You know what I mean? All right, so let's take this equation and we're going to take a look at it. And here's what we're going to do. We're going to say, all right, well, what if we left that money in there? Okay, so I'm going to write on top of here that it was 100 e to the 0.08 x, right? So this is the equation we want to plug in here. So if you're trying to set a certain goal and we want to know where it meets up to, so what I'm going to do is I put y equals because that's what I'm going to put in my calculator. That's where I put it. So here's what I have. I plugged it in y equals, right? Notice I don't have plot 1, 2, or 3 in there at all. And quite honestly, I don't really care what the graph looks like, but I want 100 e to the 0.08 x power. So we're saying, all right, x is the number of years. So now what I do is I go over and I hit second, and I'm going to take a look at the table. So first thing is our problem dealt with 5 years, and we came up with $149.18. Look at that. It's already in there. Now, if, who was this one? Latasha, Roberto, Latasha leaves this money in for 10 years, that $100 now turns into 222.55. Okay, so if we're looking for just around X number of years, we can do that. If you're trying to set a goal of, we want to make sure it reaches, let's see when, all right, so after 20 years, $100 turned into 500, almost, give or take. All right, so just gives an idea of if we could put in some different amounts. So I think the thing that's interesting here is, let's go, and I'll go off script here a little bit. So sorry, this video is going to be a little bit longer, but let's say that you had, let's insert $500. So you have a little more to invest here. So let's take a look at that table now and look what happens as we look at each of these years. Remember, the first thing was 5 years, we made $50, right? So this time, since I was able to put more money in there, we started with 500, it's now grown to almost 750. Okay, so we're finding that the rate does almost the same thing, but since we were able to invest more earlier, you're getting a much bigger return on all of these. So using that 100 to 150, we went 500 to 745, kind of nice return. So that's why people will often tell you the earlier you can invest, and then the more you can invest, the better off it's going to be in a return. And it is true, all right, especially using something basic like compounded continuously here. All right, let's get this out of the way. That was fun and all. Let me take a look at that. All right, so that kind of takes care of the first part, and I do have some homework. So if you are good with these, as we finish the video, you may want to try those if you're in my class. If you're not, you're like, dude, you can't assign me homework. I'm not even in your class. That's fine. All right, but we're going to give you some a little more complex here. So talking about an annuity, and we have some examples up top here. So retirement accounts, tuition savings accounts, and loans like 529s, things like that. That might not be true, but when I think of tuition savings, that's what I think of. I'll ask my wife later. She knows all about this stuff. All right. So here we have future value, payment. So we're getting a payment here in our dollars. Interest rate expressed as a decimal per compounding period. Okay, so this part here, even though it's a single variable in our equation, it has a little extra work involved in here. So watch out for that. And I want to point it out as we read through it. Typically calculated value we'll have after all the payments have been made. All right, so at the end of each quarter, Emily makes $500 payment into a mutual fund. Okay, so $500. All right. Okay, so that's our equal payments, R. I don't know why I keep using large parentheses with these. Okay, so 1 plus. Now, into her mutual fund, investment earns 7.88. Okay, so 0.0788 compounded quarterly over 4. Okay, so this is I right now. So we're going to close that up, and we're going to take that to the 20th power minus 1, and it's over 0.0788 over 4. So typically we don't want to show a fraction within a fraction, but I'm just trying to make sure you guys understand what's going on. That I is more than just that interest rate, right? That's why we're not using R for it, because I want you to know that this has an extra function going on in it. All right, so as far as your calculator goes, right, we're going to do this 0.0788 divided by 4, add on the 1, take that to the 20th power, and this can all be done in order if you do it this way, and then minus the 1, and then we're going to take and divide that. If you're going to do this in one failed swoop, okay, use some parentheses, divide it by the 0.0788 divided by 4, and then once you do that, I would hit an equal sign after that one. It's going to be multiplied by 500, and what we'll find out is this is going to be $12,112.46 if we follow all of that. All right, so don't be fooled here. Emily is putting in $500 each quarter. Okay, so that's 4 times a year. So she's investing, what, 2,000 for 20 years. Okay, so she's putting some money into this, and then this is going to be how much is on top of it. Okay, so that's why we call it the future value. All right, so that's kind of the big thing. So I has multiple parts. We point that again here as present value of an annuity. So again, annuity is the same idea of what we're talking about, except for that we're not talking about the future value. We're saying, all right, how much is it worth right now? We have a different formula for that. Notice it's PV, present value. A lot of the variables are going to hold true the same. And the big one here is I is still over those 2 parts as a decimal per period. Okay, so that's where we could say quarterly like we did. We could say monthly. We could say annually, so it's 1. I think that's enough highlighting. Really like the highlighter here. All right, so let's plug everything in here. Sue wants to take out a loan for $50,000. Okay, so 50,000, 1 minus 1 plus, all right, 6% interest, 0.06, and what would be her monthly payment of the loan? Term of 15 years. Monthly payments, so that's 12. All right, so you see the note down here that I is going to be 0.06 divided by 12. Okay, so it's a problem too late. That's why I wanted to point it out before. Next thing we have is close that up. That's going to be to the negative 15 years, negative 15th power. And it's over top of this 0.06 over 12. And then finally times that $50,000. So now that we have everything set, all right, so again, calculator issues, same thing. We're going to divide here, plus 1, take that to the negative 15th power. Okay, use 1 minus. Okay, you can have it say, save that answer, 1 minus the answer, and then divide that by, notice we do have this 1.005. So that's a good place to go ahead and get a decimal number. And I do have this one written down for you. Okay, 14.4166, and then finally times the 50,000. So if that all works out, then we should be at 720831.23. All right, so 15 years, we're talking about a lot of money, and 6% interest is pretty good, right? If you look things up, you're not going to get anywhere near that in this day and age. All right, so that was present value, future value, and you will have a formula sheet for these when we look at doing the test. So I just want you to make sure you know how to use the formulas and when to use the formula so we can deal with it that way. Last thing we have, and this one should be pretty basic. I just want to reiterate using logs and natural logs to solve things. Okay, so we're talking about basically compounded continuously, right? So hopefully that rings a bell now. And where t is the week time in weeks. When will the population reach 500? So 500 equals 25 e to the 0.15 t. Okay, there is a decimal point in there if we zoom in. Hopefully that came out clear in your notebook. Divide by 25 to get rid of this stuff. And this is what we're working on just the other day. So we know that's going to turn into 20. I'm going to leave a little space here because we're going to hit this thing with a natural log. So that's going to give us natural log of 20. Natural log of e will become 1, so we don't need that at all, and then divide by the 0.15. So how much time is it going to take for 25? What was this about? Population of bugs. So these 25 bugs are going to turn into 500. How long is it going to take? It's going to take 19.97 weeks because this was all after the equation. Okay, so that's a lot of bugs in about 20 weeks. And depending on if they're good bugs or bad bugs, this could be a really good thing or a really bad thing. I don't know. What makes a good bug? I don't know. If it's crunchy when you eat it. Bugs are fun, right? Cool. All right, I did highlight this one, okay, because I could chop it up as well as I could chop up the other one. So have at it there if you're good with those equations as well. If you're double checking, I do have some answers down below, so you can check those out as well. Again, if you're not in my class, I didn't just give you homework. All right. We'll talk about it in class. Have a good time.